Anyway, നിങ്ങൾ ജോയിൻ ആവാൻ ലേറ്റ് ആവുന്നതുകൊണ്ടാണ്. ഓക്കെ. Module 2, and this is asymptotic notation and its properties. We want to study, but first we want to study asymptotic notation. Asymptotic notations are primarily used to describe the running time of algorithm. The running time of algorithm describe ചെയ്യാൻ വേണ്ടിയിട്ടാണ്. Big O notation. This is big O notation. Next is theta notation. Theta notation. And the third one is omega. This is big omega. Basically, this is big omega notation. And there is an alternative, which is small omega notation. Little omega notation is also there. These three. We will commonly use these three things: big O, theta, and omega notation. Anyway, next we want to study what it denotes. What big O notation denotes. So, okay. The function f of n you are analyzing. Okay. The function f of n is equal to big of g. Actually, that is f of n. That function is equal to big of g of n. Big of g of n. G of n is basically and only if there exist positive constants c and n0 such that f of n less than or equal So this is the definition of big O notation. This is the definition of a big O notation. F of n is equal to big O of g of n. C into g of n for all n greater than n0. This is the definition of a big O notation. Okay. Then, which is positive constant C and N0 such that this condition should be satisfied. Then only we will say that f of n belongs to big of G of n. And this is the meaning of big O notation. Okay. This is the meaning of big O notation. So, right in the x-axis, we'll write uh, n value. Okay, n is the problem size, and the y-axis we'll write this f of n is the function we are analyzing. When if f of n is equal to big of g of n, then after a analyzing function or analyzing function f of n, and after a particular value n0, which is positive value, okay, after a positive value less than this function c into g of n. F of n should be always less than c into g of n. Then only we can but that notation. Okay, this is the graphical interpretation of that notation. So, f of n is our analyzing function, and after a particular value n0, f of n should be always less than c into g of n. Then we can f of n is equal to g of n if and only if there exist positive constants c. What is c? We multiply this. What is n0? N0 is a positive value. Okay, positive value. Actually, this is n0, a particular positive value. G of n for all n greater than n0. That is, after n0, after for any values of n greater than or equal to n0, f of so this is the definition of big O notation. This is the meaning of graphical or pictorial meaning of of n, and another is c into g of n. C should be greater than 0. C into g of n. You can note this curve. Okay. This is c into g of n function. Okay. There is a function. There is another function f of n. F of n is the actual our function. Okay. So when we'll say that f of n is equal to the value, f of n should be less than, f of n should be less than g of n. Then we values of n at the right of n0. This is the description of for all values of n at the right of n0. What is n0? The value of the function f of n എന്തായിരിക്കണം? On or below c into g of n. അതായത് ഒന്നുകിൽ below ആയിരിക്കണം അല്ലെങ്കിൽ above ആയിരിക്കണം. സോറി, അതിന്റെ മുകളിൽ വരാം. ഓക്കെ, above അല്ല, on or below. Asymptotic upper bound. This is another important point. Big O notation always provides asymptotic upper bound of f of n never goes above g of n after n0. Okay, now of n, c into g of n after a particular value. After a particular value means after a particular problem size. N is the problem size. After a particular മൂവ് ചെയ്യാം, ഇതുവരെ ആവാം, ഇങ്ങനെ വരെ വരാം. പക്ഷെ എന്ത് ചെയ്തിട്ടില്ല, എബോ മൂവ് ചെയ്യാൻ പറ്റില്ല. അതുകൊണ്ട് അതിനെ നമ്മൾ അപ്പർ ബൗണ്ട് വെച്ച് കൺട്രോൾ ചെയ്ത് വെച്ചിരിക്കണം. Now we need to give some example. How can prove it? Okay, a simple example. F of n is equal to 2n plus 3. Show that f of n of n. Then what we will do, we will take g of n. What is g of n? G of n is n. This is g of n, the function given inside this. That is taken as g of n. C into g of n for some positive constant n0 and c and Nn greater than n. So if we can prove this condition, then we so we need to prove this condition. If we can prove this condition for some positive constant C and N0 and then greater than or equal to N0, doing is that I'm taking giving some value for C. C is a positive constant. I given C is equal to 3. Okay. I can give any positive value. And for simplicity, less than or equal to C is 3. 3 into n. This condition will be so 2n plus 3 less than or equal to 3 square. So here is true. Okay. I given a value for C is equal to 3, then 2n plus 3 will be always below or less than or so this will be always right for n greater than or equal to 1. Okay. So we proved that. We proved this relation. Okay. Then we can say that f of n is equal to big O of n in this case. This is an example of big O notation. What is meaning? Then an example we taken. Okay, f of n is equal to 2n plus 3. Okay, we want to show that f of n below into g of n for some positive constant n0 and c and n greater than n0. So what we have done that we do some trial and error method. For example, put the c is equal to 3 to n directly we can get it. But this is the simplest case. But in the complicated cases, we want to use inequalities. This is basically an inequality in mathematical concept. Next, we are moving to what is big omega notation. So next, we are moving to the big omega notation. So what is big omega notation? The function f of n is equal to big omega of g of n if and only if there exists positive constant similar to big O notation. Positive constant C and N0 such that f of n greater than or equal to c into g of n. What is the difference? There only one difference comparing to the big O notation. Okay, n greater than n0. There exists some positive constant Cn and n0 positive constant. What will be the meaning of this? This will be the meaning. The function we are analyzing. Okay, we are concentrating on that function, and g of n is a reference function. Okay, so c into g of n is there. This is the curve of point. So f of n should be greater than or equal to. This is the curve of f of n, and it should be greater than or equal to c into g of n after n0. Okay. Before n0, it may be less than this section. You can note this section. Before n0, f of n may be less than c into g of n. No problem. But after a particular value for g of n. That is the concept. Okay. F of n should be always greater than c into g of n. Lower bound. That is, f of n never goes below g of n. Okay, it never goes below g of n after n0. Function in the term of big O notation, it means that this never goes below g of n. So it provides a lower bound. So show that f of n is equal to big omega of q. Then what we need to prove? This condition we want to prove. F of n greater than or equal to c into g of n for a positive constant c and n greater than n0. N0 is also positive. Okay. So what is f of n here? 2n plus 3. Okay. F of n is 2n plus 3. So we need to prove 2n plus 3 greater than or equal to 1 into n. I put c is equal to 1. Okay. I put c is equal to 1. Okay. Then it will be always true. 2n plus 3 greater than or equal to 1. And for n greater than or equal to 1. Okay. N greater than or equal to 1, it will be always true. And that is n0 value is 1. Okay. So this is also okay. Okay. F of n is belongs to 0. 2n plus 3 belongs to big omega 0. So we are taking simple examples and trying to understand the concepts. Okay. Next, we are moving to discuss the third notation, theta notation. In the previous class, Monster's theorem, we discussed we just familiarize this notation. Okay, this is also an asymptotic notation, and so we can express it in this way theta or in this way also. Okay, no problem. Uh, in the text, we usually this is the notation we are using. Okay. This is the notation using. Basically, it is theta notation. Theta notation. So, what is theta notation? This is the definition of theta notation. F of n is equal to theta of g of n, if and only if there exist positive constants. You can note this. There exist positive constants C1 and C2, C1 comma C2 and N0. There are three variables. Okay. Such that this condition should be satisfied. 0 less than or equal to C1 into G of n less than or equal to F of n less than or equal to C2 into G of n for all n greater than or equal to N0. For all n greater than or equal to N0. Okay, this is the condition for theta notation. Okay, the same concept. So we are considering in this way. Suppose this is C1 into G of n. Okay, this is C1 into G of n. This is another function which is C2 into G of n. What theta notation saying? After a particular positive value n0, okay, for all values of n, it should f of n should lies between f of n should be between C2 g of n and C1 g of n. Okay, that is the meaning of theta notation. Okay, this is the graphical meaning of theta notation. Similarly, we are trying to prove this. So we are taking f of n is equal to 2n plus 3, then g of n is equal to n. Show that f of n is equal to theta of g of n. So we need to prove this condition. Okay, and we are taking very simple examples and try to understand the concept. If you given an f of n and you need to prove this condition. 0 less than or equal to C1 g of n less than or equal to f of n less than n for some positive constant C1 comma C2 and then 0 and then I will get a relation like this. So 0 less than or equal to 1 star n. Okay, C1 g of n. I put C2 equal to 5. So C2 5 star. Then f of n should be f of n always lies between this. Okay, this is also true. Equal to theta of 0. Okay, so uh, okay, in this class we familiarized with the three types of notation and its graphical meaning and its okay, three type of notation. We discussed three notation, its definition, its graphical meaning, and an example how to prove uh, f of n belongs to g of n. Okay. In the next class, we will discuss some more examples. Okay, okay, thank you. And then